Alright guys, we are now looking at target 10A. This is our last unit. It's going to be a lot of information, but it's not too bad for the amount of time we have. We will fit everything in. Oops, sorry. Change this away. So our first target is the unit circle. And the unit circle is all about angles that we draw on a coordinate plane. Okay, so today we're going to look at drawing an angle in standard form using degrees or radians, and then identifying the reference angle of that angle in standard form. Okay, so when I say standard form, what do I mean? A standard form of an angle is the vertex is 0, 0. What we call the initial side lies on the positive x-axis. So our initial side always starts on that x-axis. And then we call this our terminal side, where it ends. If it's positive, it's going counterclockwise. It's going around this way, right, to the opposite of a clock. And negative angles go clockwise, so they'll go backwards. It's kind of, I always think about start going up or start going down. So positive will start going up, negative will start going down. Alright, so the first thing we're going to look at is drawing these angles in standard form with degrees. So these are all in degrees. So how we're going to start is 45 degrees. I'm going to draw my x-axis and y-axis. 45 is positive, so we're going to start going, this is 0, I'm going to go clockwise, and we count by 90. So 0, 90, 180, 270, 360. And if it's bigger than 360, you just keep counting around by 90. Okay? So then, where is 45 going to fall? Well, 45 is between 0 and 90. It is exactly halfway between 0 and 90. So I would make an angle going out, a line going straight out from 0, 0, just like that, right? And again, it's halfway between 0 and 90. And that's that angle. And that's it. That's our angle in standard form. For 200, same type of thing. It's positive. So I'm going to start going around clockwise. 0, 90, 180, 270, I get back to 360. I can keep going around, whatever. Where is 200? Well, 200 is between 180 and 270. It's a lot closer to 180 than it is to 270, though. Now we'll go around this way. While we're doing this, it's good to make note of the quadrants. Remember, we have quadrant 1, 2, 3, and 4. So this one ended up in quadrant 1, while this angle ended up in quadrant 3. A question I might ask when you draw the angle, what quadrant is it in? So it's good to know the quadrants go just like you would count, right? As you go around the circle, 1, 2, 3, 4. All right, looking at C, we're graphing a 90-degree angle. Again, I have 0, it's positive, so 90, 180, 270, 360. Well, this one's easy. It's right on one of the lines. So my 90-degree angle is right here. So if it asked you where it landed, you would just say on the y-axis. Okay. It's on the y-axis. It's not in a quadrant. It's on one of my axes. And then finally, D is negative 132 degrees. So now I have a negative angle. So all I'm going to do for negative angles is count the other way. Sorry. For instance. So I'm going to still start at 0, but I'm going to go backwards. This is negative 90. done. Negative 180, negative 270, negative 360. Alright, so I would just go backwards. So negative 132 is going to be between 90 and 180. It's actually kind of right in between the two. You don't have to be super exact. And that is also in quadrant 3. Okay. And that is it for that. Alright, let's look at our next thing that it's asking us to do. Now it's asking us to draw each angle, but now these are in radians. So remember radians? I'm going to write this one. Radians are just another form of angle measurement. Remember, 180 degrees is the same as pi. Pi radians. So half your circle is 180 degrees. Half your circle is pi radians, depending on what you're looking at. So when we're drawing an angle in radians, it's a little bit different. I always start with just 0 and pi. What we are going to do is we are going to take this bottom number and we are going to split the top half of our coordinate plane into that many sections. So that means I need 6 sections. So if I need 6 sections, I need 3 in each quadrant, right? We're only doing half. I don't care about the bottom because 1 whole pi is here. So a 1/6 of a pi is somewhere in here, okay? All right, it can only be on the top. Now what I'm going to do, once I take that number, right, once I split that up, I'm going to look at my top number. I'm going to go 5 of them. So if I start here, I go 1, 2, 3, 4, 5. Here is 5 pi over 6. And that's in quadrant 2. Okay, and that's it. So you're splitting half, right, the top of your circle into how many ever sections there are. Looking at B. Same type of thing. Right, this is 0. This is pi. So now we need 3. This line does not count as one of my 3. This line did count as one of my 6. So if that makes sense. Okay. I'm going to do the same thing. I know I can only get to 3 here. I need more. I need to extend the line to the bottom quadrant as well, right? So if you notice, I have 1, 2, 3 sections in that top half. So if I'm going 8 pi over 3, I'm going to count 8 of them. 1, 2, that line going up does not count. 3, 4, 5, 6, 7, 8. It did go around more than once. That is okay. So that's in quadrant 2. All right, let's look at our next one, negative 3 pi over 2. I'm going to take the top half and split it into 2 halves. All right, well, that's easy. That's just this line here. Let's put the bottom into halves as well. Okay. Now, I'm going negative and 3. I'm going to start going down. 1, 1, 2, 3. There's my angle. And this was on the y-axis. Looking at our next example, example B, pi over 4. I'm going to split this first half into fourths. 1, 2, 3, 4. So here my y-axis does count as the end of one of my sections. If it's just pi over 4, technically there's one of them. I'm only going one of those sections. 1 pi over 4. That's in quadrant 1. Two pi over 3. Yeah, the pi over 3 is a tricky one because the y-axis does not count as part of your section. Right? And so I use my y-axis or my x-axis, and I'm cutting above that into 3. I need a line here and a line here. Right? My y-axis does not count. So 2 pi over 3, I go 1, 2, and done. That's in quadrant 2. Negative 11 pi over 6. And I'm going to take this first, just the top half, and cut it into 6. Here the y-axis does count. Okay. And then I am going to extend that into the bottom. And then I'm going 11 of them, and it's negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I get to this line. There is negative 11 pi over 6. And that's it for drawing angles with radians. We did a lot more of those examples because radians are kind of new. Alright, last thing we're going to look at is reference angles. A reference angle is the acute angle between the terminal side and the x-axis. Always the x, never the y. Okay? So let's go back. We'll start with our first ones. We're going to look at both our degrees and our radians that we drew. And we are going to look for our reference angle. So we always want to see, is it closer to the positive side x-axis or the negative x-axis? This line is closer to the positive x-axis. So our reference angle is just how far away is it? Okay. Well, our positive x-axis is 0. 45 degrees. 45 minus 0 is 45 degrees. Okay. So A is 45 degrees. The ones in the first quadrant are super easy. The angle is the reference angle. Okay. When we move out of the first quadrant, that's where it gets a little tricky. Right? Looking at this angle, again, I want to say, is it closer to the positive side or the negative side? Negative x-axis. Right? It's closest to the negative x-axis. So we're going to be using 180. 200 is bigger than 180. So 200 minus 180 is 20 degrees. Our reference angle there is 20 degrees. Okay. Looking at C. These ones are always a little bit funky because the positive x-axis and the negative x-axis. Right? 90 degrees is equally close to that. It's 90 away from the positive, 90 away from the negative. So our reference angle here is just 90 degrees. Okay? Looking at our next one, is it closer to our positive or our negative? Right? It's closer to our negative, so we're looking for that angle. Right, so I'm going to do negative 132 minus, right, we're in the negative, so that's negative 180 degrees. So really plus 180. When we do that, you get 48 degrees. And that's it. So it's just how far away is it from that x-axis. All right, let's look at radians. I almost think a reference angle for radians, if you've drawn them out the way we have, are almost easier. Right? Looking at A, it's closer to our negative x-axis. How far is it? Well, there's one section out of the 6 sections we drew. So it's 1 pi over 6. A lot of times we'll just say pi over 6. Huh? Number 2. It is also closer to our negative, right, being here. How close is it? Well, if I continue down, there's one section out of 3 sections left. So it's pi over 3. 3 pi over 2 is, or negative 3 pi over 2 is like our 90-degree one. It's exactly halfway in between. One section this way, one section that way. So our reference angle is one section out of 2 sections. So pi over 2. Looking at D, it's definitely closer to our positive axis, right? How close is it? One section out of, this one is 4, right? So out of 4. So our reference angle there is pi over 4. Again, the ones in the first quadrant are usually just that number. This one, right, it's closer to the negative side. It's one section out of, this one has 3. So my reference angle is pi over 3. And then our last one, right here, is closer to our positive x-axis. It is one section out of 6 sections. Your reference angles are always positive. There's no such thing as negative reference angles. Okay, it's just the distance away. Alright, that is it. Sorry for the somewhat long video. Have a wonderful rest of your evening.